screen with you. All right, so your lecturer has asked me to go over the tutorial, which is your revision exercise on exponents and logarithms. It's quite a big section. There's a lot of work that is in that revision exercise, and it's not necessarily going to be possible for me to do all of that work for today. But what I will do is I'm going to discuss some of the questions that I think might have been a problem for you. And where there are similar questions, I'll do one of them, and you will be able to get a cue from that on how to handle the others. So some of them, I will answer them in full for you. In some of the questions, I'll give you a head start and ask you to complete it, possibly giving you a final answer to work towards. All right, let's start off with question 1. Question 1 says, prove that 3 to the power x minus 2 minus 3 to the power x minus 3 over 3 to the power x minus 2 plus 3 to the power x minus 3 is equal to half. Now, the whole point of this question here is to prove. Note that you are given a question. The left-hand side is the question and the right-hand side is the answer. They've given the answer to you, but they want you to show by way of some calculation that the left-hand side simplifies to the right-hand side. The point of discussing this example here is not so much to get an answer, but to show you how to lay out your work in a test. So in this case, you would start off with the word proof. Because they are asking you to prove, you're going to start off with proof, and you're going to say your left-hand side is equal to, and then we're going to start simplifying that. So you're going to get 3 to the x times 3 to the negative 2 minus 3 to the x times 3 to the minus 3 over 3 to the x times 3 to the minus 2 plus 3 to the x times 3 to the minus 3. And then you find that you have 3 to the x as a common factor at the top, and you have a 3 to the x as a common factor at the bottom. And then when you divide throughout, you're going to get 3 to the minus 2, which is the same thing as 1 over 9 minus. And when you divide the second term by your common factor, you're going to be left with 3 to the minus 3, which is 1 over 27. And here you're going to get 1 over 9 plus 1 over 27. And so you continue, and then you'll find that the terms containing an x fall away, and all that you are left with are numbers. And so you continue to simplify this here. And I'm not doing that in this. I'm going to expect you to finish that up. And you're going to say, and when you simplify it, you'll end up with 2 over 4, which is equal to half. And then you say that now is equal to the right-hand side. So that is how you go about proving something. When you are given the left-hand side and given the right-hand side, you only take one side of the question and you simplify it until you arrive at an answer that is the same as the other side. And then you say it's equal to the other side. All right, so that was question 1. Then in question 2, you had equations. And so you want to solve for x. So you know that in your exponential equations, normally, if you've got, if you have a base to some power, so for example, if you have a to the power 3x is equal to a to the power 6, then you know that if the bases are the same, then you can drop off the bases and say that implies that 3x is equal to 6, and your x is equal to 6 divided by 3, which is equal to 2. I've just used this example here to explain. However, looking at our example 2.1 here, you've got 3 to the power negative x is equal to 0.525. Now, the two sides cannot be written in terms of the same prime base. And so what we do actually have to do is when the two sides are not written in terms of the same base, we introduce the logarithm on both sides, okay? So you're going to have the log on both sides. So you're going to get log of 3 to the negative x is equal to log of 0.525. Then, using your log law, you know that log of a base to a power, the power law for logarithms tells you that you're going to have to move that power in front of the log. So that will be minus x times log 3 is equal to log of 0.525. And then you're going to get minus x is equal to log of 0.525 divided by log 3. And then you're going to get minus x is equal to 0. I think you get minus 0.5865 and so on. And if you were told, they didn't ask you in this case to round off to 2 decimal places or 3 decimal places. So I'm just going to go with x equals negative times a negative is going to be a positive there, 0.59, correct, to 2 decimal places. All right. Before I go on, I just need one person to unmute their mic and let me know that you can see my screen and that you can hear my voice. Just one person, please.
Yes, miss.
All right, thank you. Can you mute your mic back now? And then the other thing that I want to say to you is that when I'm sharing my screen, I can't see if you are raising your hand. So if there is a question that you have whilst I'm talking, you may just ask out, but please speak into your device so that I can hear you clearly, all right? Okay, let's move on. Question 2.2 says, 2 into 4 to the power x minus 1 is equal to 17 to the power x. Now, when you have equations that you are solving for a power of x, ideally you want to have all the bases the same in terms of the same prime base. Now, we've got base 2 and we've got 4, which can be written as 2 squared. But on the right-hand side, you have base 17. And we know that 17 is a prime number. It can't be written in terms of base 2. So that means now that we've got to go another route. So we're going to write this here as 2 times 4 to the x times 4 to the minus 1 is equal to 17 to the power x. So that's going to give you 2 times 4 to the x times 1 over 4. That's what your 4 to the minus 1 is equal to 17 to the power x. And then you're going to find that 2 cancels off with 4. So you're going to get 4 to the x times half is equal to 17 to the power x. Now, we've got 4 to the power x and we've got 17 to the power x. So it's nice to keep your terms in x on the same side. So you're going to write down 4 to the x divided by 17 to the x is equal to, so really basically what you've had here is a 1. So that's going to be 1 divided by your half. You know, and we're going to come to a section just now where you've got changing the subject of the formula. So you know that multiplication and division go together. If something is multiplied on one side and you transpose it or you move it to the other side, you will divide, and vice versa. So we were multiplying by half on the left-hand side. So if we shift the half to the right-hand side, we're going to divide by half. So
Sorry,
this can be
miss.
written as, yeah?
Miss, I
Yeah.
can't understand where you change the 4 to the power of x times half is equal to 1 times 17 to the power of x. How you change it to 4 to
I've
the
got,
power of x
okay,
divided by
thank you. I got your
17?
question. I'll answer. So you've got 4 to the power x, right? And then you had a 2 here, and you had a quarter here, right? So the 2 cancelled off with the 4, and it left you with 4 to the x times half. And you just had a 17 to the power x on the right-hand side, but you know that anything that's just written really means it's multiplied by 1. So in this case, I want to shift everything that contains an x onto one side. So I keep this 4 to the power x on my left-hand side, and I shift the 17 to the power x from the right-hand side to the left-hand side. I was multiplying 1 by 17 to the x. So if I move it to the left-hand side, I'm going to divide by 17 to the power x. I bring down my equal sign. I'm left with a 1 here. And if I shift the half to the right-hand side, I'm dividing by half. That is how we get that. So in this case now, simplifying this, 4 to the power x divided by 17 to the power x is 4 over 17 all to the power x. This has to do with your exponent laws that said a to the m divided by a to the m divided by b to the m can be written as a over b all to the power m, all right, is equal to, and 1 divided by half is 2. Just going to continue on this side here. There might be times when I'm skipping steps. What you will need to do is you will need to go back. Because I'm recording this, it's going to upload into your Teams classroom. What you can do is when you are viewing this recording, you can pause and you can fill in missing steps. You can redo the work because you've got something to mark against. So now we have base of 4 over 17 to the power x, and we've got a 2 on the right-hand side. So once again, we're going to introduce the logarithm on both sides. So you're going to get log of 4 over 17 to the power x is equal to log 2. And then using your power laws for logarithm, you're going to move the x in front. So you're going to get x times log 4 over 17 is equal to log 2. And then your x is equal to log 2 divided by log 4 over 17. And then at this point, you use your calculators. And I worked this out and I got an answer of minus 0.479. And I just wrote it correct to 3 decimal places. If you want to write it to 2 places, it would be minus 0.48. Now, students, I need to ask you to do this. When you are going through this work, you make sure that you do the calculation on your own, because there's no point in listening to me and going through these here, and then in a test, you don't know how to do your sequence of calculator steps. So please make sure that you do the calculator work on your own, all right? Okay, question 2.3 said 27 times 11 to the power 7x is equal to 53 to the power 4x minus 1. So in this case, once again, I'm going to break this up. We've got 27 into 11 to the 7x is equal to, and this we can break it up as 53 to the 4x times 53 to the power minus 1. Okay, so now what we can do is we can say 27 into 11 to the 7x is equal to 53 to the power 4x times 1 over 53, because that's what 53 to the power negative 1 is. Now, we want to keep our terms that contain an x onto the same side, and we want to keep our numbers onto the other side. So what I'm going to do is I'm going to move this 53 here. We're dividing by 53 on the right-hand side. So if we take it to the left-hand side, we're going to multiply by 53. So I'm going to get 27 times 53 equals, I have my 53 to the 4x here, and I'm going to shift this term to the right-hand side. And because I was multiplying that 11 to the 7x, I'm going to now divide by that, 11 to the 7x. Okay? Now, if you look at the right-hand side, students, you'll find that you've got a 53 to the power 4x and an 11 to the power 7x. And, you know, neither the bases nor the powers are the same, right? So I want to quickly remind you of one of your log laws. When you had something like a to the power m all to the power n, you said raising a power to a power, this can be written as a to the power m times n, okay? And vice versa, a to the power m times n can be rewritten as a to the m all to the n, but it can also be written as a to the n all to the m. Why? Because n times m is the same thing as mn. Mn or nm are one and the same. So what I'm going to do here now is we're going to create a situation where we've got our 27 times 53 on the left-hand side. And here we're going to write this here as 53 to the power 4 all to the x divided by 11 to the power 7 all to the x. Okay? And then that now becomes 27 times 53 is equal to 53 to the power 4 over 11 to the power 7 all to the x. Because again, the rule that says a to the x over b to the x can be written as a over b in brackets all to the power x. Okay? And then now you can introduce the logarithm on both sides. Of all the terms in here to the power x, and then you're going to use the log law to bring the x in front, and then you're going to divide throughout by logs. I'm going to ask you to finish that up in your time. And in this case, I arrived at an answer, a final answer of x equals minus 8.036. You must just please complete this sum and make sure that you get the right answer as me, or if you've got a different answer from me, then you can check amongst each other or verify with your lecturer. Okay, bear in mind that in light of your test for this week Friday, you're going to have to go back to this tutorial and review it and work through things where I've left blanks. Okay, right, question 2.4. Your question 2.4 says 2 to the power 2x plus 2 minus 16 times 2 to the power x plus 4 is equal to 0. Now, you've got a base 2 to the power 2x, and then you have a base 2 to the power x. When you have a situation like that, you know this is going to lead to a quadratic equation, okay? So in this case, we break up your first term as 2 to the power 2x times 2 squared minus 16 times 2 to the x plus 4 equals 0. And then you can write this here as 2 to the x all squared, again, employing the raising a power to a power rule, times 4 minus 16 times 2 to the x plus 4 is equal to 0. Okay. And then you can say, if you want to, at this point, you could say let 2 to the power x equals k. So therefore, now we have 4k squared minus 16k plus 4 equals 0. You have a common factor of 4 throughout. And when you have a common factor, which is a number, a numerical common factor, you should ideally divide by that common factor. And you're going to get k squared minus 4k plus 1 equals 0, right? Now, you will try to factorize this, and you're going to find that it doesn't factor. You must try to do that when you are completing this. So you can use the quadratic formula, k equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And you're going to get k is equal to 2 plus or minus the square root of 3. Again, I want to suggest to you, you go back and you fill in the missing steps. You need to bear in mind that we are working with limited time frame here, and I'm trying to cover as much as I can for you in preparation for your Friday's test. Okay. Then you got your k is equal to 2 plus or minus root 3, but you weren't asked to solve for k. You weren't even given a k in the question. You were given an x. So you go back and you say that implies now, you go back and you replace your k with 2 to the power x here. So you're going to say 2 to the power x is equal to 2 plus root 3, or your 2 to the power x is equal to 2 minus root 3. Okay, and then you're going to introduce the logs on both sides. Okay, so log is equal to log. And you're going to simplify all of that, and you're going to get x is equal to 1.9. Please make sure you work towards that, and you do exactly the same thing here. You're going to introduce the logs on both sides, and you're going to simplify, and you get x is equal to minus 1.9. Okay, so that is how we solve question 2.4. Okay, moving on, you've got 10 to the power 2x plus 10 to the power x plus 1 minus 10 to the power x minus 1 minus 10 to the power 0 is equal to 0. So let's simplify all of this here. All of them are base 10. So you're going to get 10 to the x all squared plus, here you'll get 10 to the x times 10 to the 1 minus 10 to the x times 10 to the minus 1 minus, and 10 to the power 0 is equal to 1. It's equal to 0. Okay. So you'll find that you actually have two terms here in 10 to the power x. So let's simplify that. So you've got 10 to the x all squared plus, you can pull out your 10 to the x as a common factor just for those two terms there. You're left with 10 minus 1 over 10 minus 1 is equal to 0. So that's going to give you 10 to the x all squared plus 10 to the x times, here you've got, that's over 1. Your LCD here is 10. So 1 can go into 10 10 times. 10 multiplied by 10 is 100 minus 1 is equal to 0. You'll have 10 to the x all squared plus, here you're going to get 10 to the x times 99 over 10 minus 1 is equal to 0. right? So you can say let 10 to the x equals k. Should have done that in another color. Let's do that now. So then you're going to get k squared plus 99 over 10 times k minus 1 is equal to 0. Okay, so from here, you're going to multiply through by your denominator of 10. So you're going to get 10k squared plus 99k minus 10 equal to 0. You try to factorize that, and it actually does factorize. You're going to get 10k minus 1 into k minus 10. Sorry, k plus 10, because the last term is negative there. And then you're going to get k is equal to 1 over 10, or k is equal to negative 10. Moving on up here, you're going to say now, that implies that, what did we let our 10 to the x equal k? So you're going to say that implies now that 10 to the x is equal to 1 over 10, all right? So 10 to the x is equal to 10 to the minus 1, and x is equal to minus 1. Or, I'm just writing it below because I don't have any more space on the side. You're going to have 10 to the x is equal to negative 10. And very important here, this equation here has no solution. Okay? Remember that a base to a power can never equal a negative number. Okay? I'm sure that your lecturer showed you the exponential graph and how the exponential graph lies above the x-axis. It doesn't lie below. It doesn't have negative y values, the basic exponential function. And so therefore, this here is your only solution. X equals minus 1 is your only solution. Okay. Now, this is a very similar question to the previous one, except that there we were dealing with base 10, and here now we are dealing with base 2, base E. So you're going to be doing exactly the same kind of stuff, all right? And so you're going to find that you're going to write this as e to the 2x times e minus 2e to the x times e squared plus e cubed is equal to 0. Very important, you have a common factor of e throughout. And remember that e is not a variable, e is a number. Okay, it is the irrational number 2.718281828 recurring. But we don't write it as such, we write it as e. And so because e is just a number, it's like in the previous example when we had a common factor of 4, we pulled out, we divided throughout by a common factor of 4. So here you can divide throughout by e. And when you do that, you're going to get e to the 2x, which is the same thing as e to the x all squared. This thing here is e to the x all squared minus, and when you divide this term here by your e, you're going to get 2 e to the x times e. The e squared divided by e gives you e, plus your e cubed divided by e is going to give you e squared equals 0. Okay, now students, it turns out that this here is a perfect square trinomial, and it factorizes as, if you want to do you can see that your last term is positive. So if you factorize e to the x all squared, you're going to get e to the x times e to the x. When you factorize e squared, you're going to get e times e. Multiply across, you're going to get e to the x times e, And here you're going to get e to the x times e. And if you add these two cross products, it gives you the middle term. And because there's a minus sign, you can put a minus sign there. So your factors are actually e to the x minus e all squared is equal to 0. It's e to the x minus e into e to the x minus e. Now, please note that this is how I factorize a quadratic trinomial. You don't need to unlearn anything that you learned at school or previously. You factorize in a way that works for you. So now you're going to say, therefore, e to the x is equal to e, because you're saying that this e to the x minus e is equal to 0. And so e to the x is the same thing as is equal to e to the 1. And so x is equal to 1. And that is your only solution. Okay. And then in this case here, in question 7, it's a very similar question again, where you've got your e to the x all squared, right, minus e plus 1 times e to the x times e plus e cubed is equal to 0. You've got your e to the x all squared minus, you multiply this term on the outside by e, so you're going to get e to the x times e is going to give you e to the x times e squared. And a negative times this positive is going to give you a negative. And when you multiply this term by 1, you're going to get e to the x times e, all right, plus e cubed. Equals 0. And now you've got 4 terms there. And the best way to work forward from here is to do grouping. You group these 2 terms and these 2 terms here. And you'll find that you're going to end up with a common factor. So I'm going to give you a clue here. You can use grouping, and then you will solve each equation on its own. And I'm just going to give you your final answer here. Is going to be x is equal to 2 or x is equal to 1. So you're going to finish the rest of this on your own, okay? But working in exactly the same way as the previous example with e, except that here you had to use grouping in order to arrive at your answer. Right, question 2.8, you've got 1 over x minus 1 over root x minus 20 is equal to 0. So the best way to do this here is you can make x the subject of the formula, and you can work from there. You can say your LCD is equal to x, right? And so you're going to multiply throughout by that. So x into x 1 times 1 is 1 minus x divided by root x is root x. So root x times 1 is square root of x minus, and here you've got over 1. X divided by 1 is x. And so x times 20 is going to give you 20x is equal to 0. Now we have a question that has a term in x and a term in square root of x. What you need to remember here is that 1 minus root x minus 20x is the same thing as 20 root x all squared. So you have a quadratic equation in square root of x. If you wish, at this point, you can say, let square root of x equal k. So you're going to get 1 minus k minus 20 k squared equals 0. And then you can factorize this, okay? And it will factorize. Okay, and you're going to get k equals a number. You're going to get k equals 1/5, or k is equal to minus a quarter. And then finally, you go back and replace the k with square root of x. So you're going to say that implies that square root of x is equal to 1/5, and your square root of x all squared is equal to 1/5 all squared. You want to get rid of the square root sign, you're going to square both sides. And so x is equal to 1/25, or you can say root x is equal to minus 1/4. And if you square both sides, you're going to get x is equal to minus 1/4 all squared, which is positive 1/16. And that takes care of all of the equations that were given to you. Now we move on to the formulae. So changing the subject of the formula is something that you've done at school, but you'll find that the examples that are given to you now here at university, lots of them involve squares, square roots, fractions, e to the power x, ln. Okay, remember that e and ln go together. So in this case, you want to make p the subject of the formula in this question here, which means that we've got to systematically move all the other variables to the opposite side until we are left with only a p standing by itself. So we start off with, I can move this 8. Because I was dividing by 8, if I move it to the other side, I'll multiply by 8. Okay. And because I was multiplying by L on the right-hand side, if I move it to the left-hand side, I will divide by L. Okay, so that leaves me, I moved the 8 and I moved the L, it leaves me with WL plus 2P. And so you can say your 2P is equal to 8 ln M over L minus WL. Okay. When you have a question like this here, it's nice to simplify the one side. So you're going to say 2p is equal to, on your left-hand side, you've got an LCD of L. So you're going to get 8 times ln M minus WL squared. Okay, because this is, remember, this is over 1 here. Okay, and then finally, you're going to say P is equal to 8 times ln M minus WL squared over L, and you're dividing by the 2. But dividing by 2 is the same thing as multiplying by half. And by the way, another thing that you can do is to move this 8 to the power of M here. So that's also a possibility. So you could write this as ln of M to the power 8 minus WL squared over L times 1/2. Because remember, you were dividing by 2/1. It becomes 1/2. And so that becomes now ln of M to the power 8 minus WL squared over, and 2 times L gives you 2L. Okay, that's how we go about changing the subject of the formula in this case. Right, question 3.2. This is a pretty straightforward one. The first thing that you're going to move is this V naught. So you're going to go V over V naught is equal to I plus, you want to make T the subject of the formula, so it's nice to open out that bracket there. So you'll get BT plus, no, sorry, minus, because positive times a negative is a negative, B times T naught. And so your V over V naught is equal to, sorry, it's not equal to at that point. I can actually remove that equal sign there. I can move this thing here and move this thing here over. So that will become minus I and plus B T naught is equal to BT. And now all that is left is for you to get rid of this B to the other side, which means you're going to divide by the B on the other side. But students, again, it is good practice to actually, you can see that this is over 1 and this here is over 1. So you can write down here, your LCD is V naught here. So you're going to get V minus I times V naught plus B T naught V naught is equal to B times T. And then on this side here, you can now, we know we're going to divide by this B on the other side. So I can say T is equal to V minus I V naught plus B T naught V naught over V naught divided by B over 1, which is the same thing as multiplying by 1 over B, exactly as I did in the previous one. See, dividing by 2 was the same thing as multiplying by half. So dividing by B is the same thing as multiplying by 1 over B. And so you can get V minus I V naught plus B T naught V naught over B times V naught. Right, if you're looking at this question here, the first thing that you're going to move is this 2 pi here. And because you're multiplying by, can I please ask that somebody mute their mic?
I have a question.
Students, there is somebody who's got their mic unmuted. Can you have a look at who it is and ask them to mute their mic? Thank you. All right. So you are multiplying by 2 pi. We want to make h the subject of the formula. So we're going to have to start moving things one at a time, starting with the 2 pi. So you're going to get ln t over 2 pi is equal to the square root of all of that. Then to get rid of the square root, you're going to square both sides. So you're going to get ln t over 2 pi all squared is equal to h squared plus k squared over g. Then the next thing that you're going to do is you can move this g over. So you're going to get g times ln t all squared over 4 pi squared. I just opened out the brackets there, right? Is equal to h squared plus k squared. And then in the next step, you're going to move this k squared over. You're going to subtract it. And then you're going to be left with an h squared. And you want to find h, which means you're going to have to introduce the square root. So you're going to finish up a few steps here. And your final answer is going to be h is equal to plus or minus the square root of g into ln t all squared minus 4 pi squared times k squared all over 4 pi squared. Bear in mind that you had an h squared, and when you want to get rid of a square, you introduce not just the square root, but this plus or minus is an important part, okay? If you don't have the plus or minus in a test, you will lose a mark. All right, P is equal to P naught times e to the kh. So in this case, you want to make k the subject of the formula. So you're going to have to divide firstly by the P naught. So you'll get P over P naught is equal to e to the kh, e to the kh, right? Now you want to get rid of the e, all right? And so to get to, remember that you would have learned in class that to eliminate an e, you introduce the ln on both sides, right? E and ln go together. So you're going to have ln of p over p naught is equal to kh, and then you finally can make your k the subject of the formula, and you're going to say k is equal to ln of p over p naught, all divided by h. Okay, this is a very important question, but by the way, they gave you some values here as well. So after this now, you complete this, and then now sub the values. And I'm not sure, you'll have to substitute the values and get a final answer. Right. So if you're looking at 3.5.1 and 3.5.2, they are both the same as, well, similar to the 3.4 that we just discussed, because they have an e to some power. You've got e to the power, it's blocking this ribbon here is blocking that, but it's e to the power negative t over rc, I think. And you work in exactly the same way. You follow my example from 3.4 and you complete 3.5.1 and 5.2. Okay, please just give me a moment. I need to. Okay, question 3.6, you've got y is equal to e to the 2x plus 1 over e to the 2x minus 1. And we want to solve for x. So we've got to bear in mind that this is really y over 1. And then the best way to get rid of fractions in this case is to multiply across. So you're going to get y into e to the power 2x minus 1. If I multiply across this way here, and when I multiply across this way here, you're going to get e to the power 2x plus 1. So you have to, the idea is to keep all the terms that contain an x on one side. And so in order to do that, we have no choice but to open out the bracket on the left-hand side. So you'll get y e to the 2x minus y is equal to e to the 2x plus 1. Y e to the 2x, I'll move this thing over. So I'm going to have to subtract e to the 2x is equal to, and I'm going to move this thing over to the right, so it will give you positive y plus 1. Now you can pull out e to the 2x as a common factor, and you got y minus 1 is equal to y plus 1. And so you're going to get e to the 2x is equal to y plus 1 over y minus 1. And so now you need to get rid of this e here. So we introduce the ln on the opposite side. So you'll get 2x is equal to ln of y plus 1 over y minus 1. And x is equal to half ln y plus 1 over y minus 1. Okay. Question 3.7 is the last one that I'm going to be able to discuss with you, because I've come to the end of this hour, and you're going to have to finish up the rest of these on your own. I'll probably give you the final answers then, just to help you out. So you've got, in this case, they want you to make, they wanted you to make y the subject of the formula. They wanted you to make y the subject of the formula. So you remember the rule that says log A minus log B is equal to log of A over B. But before we do that, let's simplify the stuff here. It looks pretty complicated, so let's simplify it. So you've got log, and your LCD here is root x, okay? So remember that this is over 1. So you're going to get root x divided by 1 is root x. Y root x times root x is yx. X times root x is x, okay? Plus y, okay? And we bring down everything as it is. Okay. Then now you've got a situation where this is the equivalent of A, and this is the equivalent of B. And you know that B. And you know that log A minus log B is equal to log of A over B. Okay? So that is the rule that we're going to apply here. And so you're going to get log, a single logarithm of yx plus y over root x divided by this root x here, which is simply root x over 1, is equal to log, this is small letter b. And so this is now log, we don't put an equal sign there, you're going to get yx plus y over root x times, this was divided by root x over 1, so it's times 1 over root x is equal to log b. So that's going to give you, remember at the bottom now, you're going to get root x times root x is x. So you're going to get log of yx plus y over x is equal to log b. And then now we can drop off the logarithms, and then you're going to get y into x plus 1 over x is equal to b, and your y is equal to bx divided by x plus 1. We are dividing by x here, we multiply by x. We are multiplying by x plus 1, we divide by x plus 1. Okay, so students, I'm actually going to stop sharing at this point, and I'm going to stop here. I can't do any more than this for now. Okay, and I'm going to end this lecture, but this this tutorial will upload into your Teams classroom. You can go back and look at that. There's just 3.8, 9, and 10 in formulae that needs to be done. Okay, so you can do that. If you see your lecturer again, you can maybe ask him to go through that. Okay.